Alright, so in this video, I got all 6 coils in, just on the top surface. Just easier to wire. I don't know, just seems easier. So, got the same capacitor. This is the resistance throughout every coil. So, half a mega ohm, quite a bit. And for one coil, it is 80 still. Before I had it in parallel, but I didn't realize one of the wires I had to join these, which was very difficult because the fact that it didn't want to solder for crap. It's so thin. But I had to do that with several of them, unfortunately. But now I'll show you how well this works. Now I'm gonna have to set this down for a moment. Alright, get this back on there. Alright, so now we're wired up. Only at 2 volts. Get a little start. And the crazy thing is, see how quickly it's depleting with it running, but now, even, because of the natural discharge of the capacitor, that's without it running, and it's still bleeding that fast. Now, if I get it going again, you'll see it's really not that much faster. And there's still torque behind that. I'm putting some friction on there and it's still pushing it. Alright, and I will run this voltage up. Got it to about 300 before, and I kind of started running into arcing issues, I think, because it was sticking. So around like 250, it seemed to be the best. I need to get a better. I might just make my own with a magnet on there. It's always hard switching high voltage. Now, if I did this like before, I swear, I think I ran like 6 hours on this at max charge at 250. And, this thing barely drained, and that's only a 220 microfarad capacitor, and this one's 400 or 4,500. So, yeah, that's quite the difference. Well, this has a 450 volt capacitor voltage. Alright, so we'll probably get close to stopping it around here. Yeah, you can definitely feel the power difference. There's definitely a lot more torque. See, that's the stick, it's getting sticky now. Alright, now I'll cut it off here. It would be even more efficient if it wasn't at this voltage. The contacts are, I think they're kind of getting stickier. I don't know, it just seems like it's not working as good. Seems like it's not too bad, but it's still there. But yeah, when you think this tiny little capacitor is running this, I mean, it's not tiny little, but it's of decent size. This is what it is. That's what's running it, just one. I'll probably put this up next to it, although there's 3 in parallel and 3 in series, so the max output would be quite a bit higher. It'd be 900 plus 450, around 1300, 1350. Well, you could call it actually 1500 volt, because I'm sure they can go up a little higher than that. So I just got to get a better switching mechanism. But yeah, it's still running and still above 100, 200. Oh, there we go. Now it's below 200. I barely used anything at all. And the crazy thing is, there's still torque there. And you can see on a dead short, this is like dead short, it's still barely draining that capacitor. It's crazy. It's acting like it's like a battery. Now this thing would act like it's a battery. Let's see. It says 4500. That's 10 times the amount. Or wait. No, it's way more than that. That's like 220 times, say 10 would be 2000. It's 20 times. This is 20 times the capacity of that capacitor. So that just goes to show that how efficient this motor is right now. And it'll run very slow, obviously, at these voltages, because there's just so much resistance. There's half a mega ohm of resistance, which is crazy that it even runs. But because each coil, it's a one continuous wire, and like I was saying before, if you took a resistor and did the same thing to drop it down to half a mega ohm of resistance, and you put it to even like, let's say you used 20 gauge, for example, and you put 100 or a half a mega ohm resistor in line, it wouldn't turn this motor because it just wouldn't work. It wouldn't be enough current flowing through the coil to make it work. But now that you're running all the coil, it's all coil, there's no resistor, then it can work because it still generates enough of a magnetic field, even though that there's like such a low resistance. Or I mean high resistance, my bad. And it's able to run extremely efficiently because of that. It also, at the same time with it running, it's generating power because it's just, the function of a motor slash a generator, I guess. Like if I spin this now, you'll see that it starts increasing. Actually, it's not really doing much at all, is it? Interesting. It's not spinning. Well, now it's taking power from it. Not spinning. It seems like it's stabilizing a little better. So you could call it like it's going on more like an electric flywheel. If I were to take this lead off and spin it, it would spin very easily because the inertia, and it's very little resistance on the rotor and the bearings. So now having this in line with it, it's basically like an electric flywheel, but this is the capacitance. I think it's pretty cool. I just need to get it to be able to run at higher voltages so we can get higher RPM and see what kind of output we can get. But that's the real challenge now, is to get a good switching mechanism for this thing. Thinking of making my own, putting a magnet on there and trying that. I'll probably even get it to run on this, but that's such a low voltage, so I'll probably not. Need high voltage. Even just like a regular, I forget what kind of cap this is. It's not a ceramic one, I can't remember. Might be. But I might almost be able to get it to run just on that. And as the voltage gets lower, slower to run obviously, and then the less power it'll take. So if I drain this down, which takes a lot to drain it down, even though that it's shorted to the coils. God, yeah, that's crazy. Yeah, that's gonna take way too long for this video. Definitely doesn't spin that fast though, but it doesn't really matter. It's just the fact that it's this efficient and able to run at that high of resistance. I think it stops around like, I want to say 20 volts. It starts to not work. I know how to do this faster. Oh, that was too much. Let's bump that up. Right. Now, let's see if it still runs on that power. Yeah, it's still running on that voltage. That's crazy. Even though it's a high voltage, technically speaking, but not for this. Oh, no, it's still working. Just barely. And that's too little. So I think 40 volts might be the minimum. Alright, let's try that. Yeah, 40 volts is about the minimum. Yeah, 40 is about the minimum for this thing. Alright, this video's getting longer. I'll cut it off. I'll see you later.